Okay, this will be our last talk of the day. Saving the best for last.
Oh, yeah.
This is Matt Podwysocki, and he is going to talk about streams, specifically not crossing them, because that makes bad things happen with ghosts, obviously. All right, here you go.
All right. Thank you very much. Hello everyone. I am Matt Podwysocki, and known unoriginally on the internet as Matt Podwysocki. I don't know why I didn't choose anything more interesting than that, but you can find me on GitHub, Twitter, etc., all there. I'm also, along with Chris Williams, the co-host of the JSConf Live podcast, so whenever we actually get around to doing a show, check us out. So today I'm here to talk a little bit about streams. So when I say streams, what does that mean? I'm not in a very literal sense talking about node streams, although I recently did a talk at Node Dublin exactly on that. No, what I'm really talking about here is more along the lines of data streams. So whether it's things like GPS data, whether it's Twitter, etc., in kind of a general term. I naturally work for this small company you may have heard of called Microsoft. And I'd like to say that I'm bringing a little bit of the metal back to Microsoft. All right, so this term callback hell, how many people have heard that? Most people. All right, how many people have actually run into this where suddenly they get this nice big indent here, what's commonly called the Pyramid of Doom. So in this particular case, we're checking to see that we're doing a request, and then going from there, getting it from a database, checking for errors at each individual step. So, you know, when you just get into this, you're like, oh, okay, I'll just go on to the next step. I'll go on to the next step. I'll go on to the next step until you find that you're like, oh God, where is the state in all of this? And where's the error propagation? So it goes like this, and all the stack traces get very, very weird very quickly. So how can you really compensate for that? And one of the ways that many people do is, of course, extract a lot of these functions into named functions. Max Ogden, so really awesome guy, has a great site called callbackhell.com, I believe, where he goes around some of the techniques. But more along the lines of a lot of people have been really into the idea of a promise. How many people use promises in their JavaScript? Actually, quite a few. So for those who don't know, a promise is kind of is an object or a proxy for a value that might come in the future. And that when you're ready, then you can yield the value and the callback will fire with the value. So it's actually an old term, comes back from the 1970s or something like that. And more along the lines of the community is kind of trying to standardize on this through the CommonJS promises A spec. Chris Zip did a lot of work, and then it started to make an appearance in the Dojo toolkit, as well as jQuery, starting in probably 1.5 or so. And as you probably saw today with the WinJS and in Windows app, that the team has also pretty seriously embraced promises. But nobody's really talking about events and composition kind of in the same way. Now, what if we could start combining together events as they're coming along, kind of like Legos in the same kind of way that you would do for promises. So promises are a single value, whereas events usually are 0 to infinite values. And you really wonder about composition and so forth. What I mean by composition is, what if I can take these particular events and mash them together, such as, say, I want to say mouse down and mouse move, so I'm trying to mimic some sort of dragging effect. And now, what I want is I want to combine that two logic together, and then when I want to stop listening, I can just somehow, it would magically know that both of those handlers I need to get rid of. And so how do you also merge these kinds of things without having a lot of really nasty state just hanging around here, and then you would have to clear it out. For example, if you wanted to sample events. So I want to say I want to receive every half second I want to get an event. So what would mean usually is you would have some sort of array or buffer out there, then you would start shoving things into it, and then eventually you would have to clear it out, and then it just becomes a jumbled mess very quickly. So in other words, what I really want to do is cross the streams. So the rest of the talk, I'm just going to abandon everything else and talk about how monads are going to save the universe. Functional programming is going to rule the world, and yeah, next year is the... No, I'm not going to go there. Yeah, I'm not even going to talk about category theory, as tempting as it might be. No, I'm tired of hearing a lot of the times when people talk about event composition and so forth by talking and jumping more into the academia portions of talking about monads, category theory, etc., that it's not really solving anyone's real-world problems. So instead, what I'd like to say is leave a lot of the theoretical stuff behind, and then use a lot of the techniques that you already know. So one of the things that I actually write at Microsoft, so I'm part of the cloud programmability team at Microsoft, and the overall goal of the team is to think about new ways of querying data. So it's all part of the SQL Server team, kind of a skunkworks kind of underground kind of place. So we created a few things. We had a long time ago a project called Volta, which was the idea that you could recompile your app into .NET or JavaScript by just hitting a build button, and other really crazy stuff like that. So we had a project called Reactive Extensions for .NET and JavaScript. So both of them we just released open source on CodePlex, so you can go and find them there. And also that it's available on NPM, it's available on NuGet, it's available everywhere. So it's a platform-independent look at JavaScript eventing. So you look at libraries such as async and all that are more flow control libraries that are more focused on Node. What we're trying to do is focus instead as a holistic, can we solve the browser, can we solve the server all at once? So really what is RxJS? It's a set of types representing asynchronous data. So what I'd like to say is asynchronous collections, as it were. And then we'll have a kind of a set of operators on top of that you can combine them, you can filter them, aggregate them, and so forth. And then one of the really more interesting aspects of this is how do you parameterize the concurrency, meaning where and how does it happen? So if we separate all of that out, it gets pretty interesting. So as you probably see, oh crap, not another flow control library, and not another person coming up here and say, I have a really great idea, and so why should I even bother? Now, like I said, one of the main goals that we had was to think about it holistically in more of evented style. So most of the flow control libraries out there are usually built around the ideas of promises and so forth, where you have a single value and then you continue or you do your error propagation. We took it from the opposite angle and we said, okay, well, why don't we just do events instead, where you can get 0 to infinite values. So that's where we started with this, and we worked increasingly to come up with these kinds of scenarios and say, well, this is why we're different. So let's actually walk through some code to actually see what I mean. Now, when I say let's say rich composite events is one of the things that we do fairly well. So one of these scenarios is I want to be able to create a single event or a single object which encompasses a mouse drag or mouse drag and drop. So in this particular instance, I can say whatever the mouse down, I'll just say, for instance, it's an observable stream or observable collection. We can compose it together with mouse move and projecting all of this stuff along the way, and then take until mouse up. So it's basically combining together mouse down, mouse move until mouse up, And what that gives us is an object we can then pass around to anyone to say this is a collection of mouse drags. So in there, it's basically just a collection of coordinates, of deltas, as it were. So what's really nice is the fact that you can start passing these around as real objects, whereas in traditional JavaScript, you have an event emitter, which is kind of a magic unicorn value of collection of events, whereas this one is actually an event stream itself that you can pass around. Now, you can certainly do regular flow control like everyone else does. So for example, in this particular instance, we can do a kind of a dictionary lookup. So when you're doing a search, and you want to be able to find a particular thing on the internet, here's what you might do. So for instance, we can listen on the key up event. Now, if I'm a really fast typer, I can absolutely flood the service. So at a certain point, I might want to back it down a little bit. So for example, I go, OK, pause for a half a second. OK, now go. And not only that, but even taking it a step further to say distinct until change, meaning I can keep on hitting the left arrow, right arrow, etc., and it would still fire because, well, obviously the key up happened. Well, but if I do up here and I say project or map out the value from this particular input, then I can say, well, the input actually didn't change, so I'm not going to fire it at all. And the other things that you can do here is you can handle out of order search results. So another thing about asynchronous programming is the fact that order does matter. So if I type in React and then I type in reactive, well, it's not really quite sure which one's going to come in first. That you kind of somehow have to take it on a wing and a prayer. I've been on my phone many a times and I've hit search, and then the first one shows up last, and I'm like, ugh. It's a terrible experience. So in fact, we have a kind of a switch latest which goes and truncates that automatically. And then you can bind all of the results there. All right, now here's an eye chart. But the idea behind this one is the fact that you can do a lot of really complex event processing. So it's not just flow control. It's not just rich events. But you can actually do group bys. In this particular case, what we're trying to do is say, we're going to listen for a stock stream. We're going to calculate a differential between the current and the previous one and see if there is a spike for a particular stock stream. So this is great not only on the client, but also on the server as well. So we can figure out where the prices actually spiked. And yes, I can do the Konami code. Yes! The sole reason for it being here, absolutely, was what I ended up starting out in the beginning. All right, so what is this? Well, it's really a set of types that we're talking about. So you saw me using observables everywhere. So what does that mean? So what we have is we have kind of two main objects that you're going to think about. The observable object, which is a stream of values. And then we have the observer, which is the subscriber or the receiver of those values. So you just have a single method, well, largely just a single method called subscribe. The observer calls it, passing itself in. And then when it's ready, the observable starts firing the onNext call. And optionally, if there are particular errors that happen or completion that happens, that's propagated too. Now, we had before there, we had a specific kind of grammar that we had where you had the onNext, onError, and onCompleted. So the onNext could happen 0, could happen infinite times. For a particular call, it may fail for whatever reason. So we have an onError handler. So you don't. The problem a lot with asynchronous calls is that there's no such thing as a try-catch. So you need a good error handling model to do that. And then onCompleted as well. So for example, we could have an infinite stream of values and it never ends. Ultimately, we could have one that fires 2 values and then calls an onCompleted call. Perfectly valid. We can also have one that yields 3 values and then an error. And finally, now that doesn't work. What this shows is it's overlapping. Well, the way that we do it is, through internal queuing and so forth, is that you cannot have values that overlap, and we can't have a value that shows up suddenly after we stop listening. So once I talked about the whole mouse drag effect, is that these objects or these observable values or observable collections are just first-class collections. So what you can do is you can have it passed as a parameter or returned from a method. So you can create query libraries just as well for testability, mockability purposes. Is that you can suddenly replace this at runtime and be able to suddenly run all of your computations as if it were some sort of async method. So the second part of this is a set of operators. Now, what I'm showing you is a lot of fluent style syntax, but quite honestly, you already know this. You already know ES5 collections. You know for querying you have concat. To concatenate, you have every to determine whether everything's in a list or not satisfying. You can filter. You can map. You can reduce. You can determine whether some match or not. And then you could subscribe, as it were, by calling for each. So nothing that I'm talking about here is actually all that foreign. What we have is we have concat all. But the beauty of JavaScript is if you don't like the names that I use, just remap them. My feelings wouldn't be hurt by that. So really, observables are just data streams. So once again, we can take a stream of values. We can then filter it basically where it's green, and then we create a new stream at the bottom here, never ever touching the original stream. So we're not killing the original. We're not causing some weird side effects. We're actually moving on to the next one. And since we're talking about asynchronous values, what we're really talking about is we have a notion of time. So now I can take said dots, delay it by a second, and then suddenly, now all the streams are then delayed. So you can have notions of time built right into your collections. That's a lot of operators, but needless to say, there are a few categories that you might be interested in terms of doing composition, doing querying, etc. So some of the basics that you might want to use, the select for the map, select many for combining streams, distinct for I only want distinct values or distinct until changed to say whether or not the value has changed for one reason or another. And then group by. So if you think of SQL, you could probably say that Rx looks very, very similar to that. And then we also have like stake and skip, so I can take 5, skip 5, skip for a given amount of time, etc. Aggregation, kind of the same thing, is we can do all the things that you saw for ES collections. One of the differences is being scan, which is the ability to do incremental aggregates. So, for example, I wanted to do running calculations as my things are going on. And because these are asynchronous and exceptions are really hard to deal with, how do you manage? Well, what we have a few ways of thinking about that as well. So kind of your try, catch, finally logic is built right in. So you have catch, you have finally. You can do some VB stuff with on-air resume next, where you just say, don't care about the particular exception that came through. So basic flow control, as you might see as well. And more along the lines of a lot of the flow control you already know, such as fork join, zip. So the idea is that you can take two observable sequences and just start combining them together as they happen. merged, you can kind of do the same thing, is incrementally start throwing these kinds of collections together. Time-based, so if you're doing some really complex stuff, such as I want to find the differences between all of my things that have fired, time interval, I can tell you exactly how fast or slow things are going in your system. So when you're thinking about really more on the node side of things with really compute-intensive operations, this is pretty useful. As well as finding out if a particular process has gone rogue, you can do a timeout and kill it. And of course, you can get really, really complex here. But then again, we came at it from an idea is that we really want people to be able to query things as much as possible and not just be a normal flow control library. So things such as buffer, I can say, give me the past 10, or give me everything, all of the events that happened in the past 2 seconds, 3 seconds, etc. So kind of going a little bit deeper. So the last real part of this is actually a part that's completely separate from the rest. So now that you see kind of that you have these observers and the observables, but how does the actual work happen? And what we do is that we have to think about it a little bit differently. How do we kind of run timers or anything like that? But more importantly is since we introduced concurrency, we want to be able to yank that out as well or change it on the fly. What we really want to do is have kind of a shape that everyone conforms to, so we can say scheduler.schedule at a given optimal time, give us some cancellation to say, do this, oh wait, no, don't do this, and have a way for it to not do that. So the idea is that you could have many, many different implementations, whether it's immediate, whether it's in a queue, whether it's using set timeouts and always going through that event loop. Or, for example, you want to say more of a virtual thing. I want to do it for testability purposes. How many people here write asynchronous unit tests? Quite a few people. So instead, I got really tired of writing asynchronous unit tests. So what I did is I realized that what we could do is actually yank out the whole concurrency mechanism altogether and instead kind of introduce some sort of running mechanism which then traces through all of the particular observables that fire at a given time. So for example here, I have onNext firing at 300 milliseconds and then JS firing at 400. And then when I actually run it, all I want to do is return the length of each of those items in there. So what I get is I get 8 and 2 at 300 and 400. I could tell you exactly what the data is and when and where it happened. All because I was able to just parameterize the concurrency in there. So no more asynchronous tests are actually required to do that. So once again, we're up on NPM. So if you say npm install rx, boom, you get it. NuGet. So you know, I showed a lot of the kind of the core fundamentals. But a lot of the times, if you're continuing to use libraries like jQuery, Dojo, etc., we have a bunch of bindings. They're in NuGet as well. They're also on GitHub. So if you want to go out and check it out, we're at Reactive Extensions on GitHub. We have a bunch of them out there, and as well as if you want to take a look at the code, source code, there we are. We're also a little bit mirrored on GitHub at the moment, but in there we also have some samples, and really would love some help with this, documentation, etc. So some of the ongoing work, obviously documentation, tutorials, etc. But where's the vision? Are we actually done yet? No. This is actually some of the beginnings really of what we want to do. So scaling is always one thing that you always have to worry about with streaming libraries. So none of the things that I really showed you today had really anything to do with some of the more pressing issues, such as if I wanted to handle back pressure, meaning that I'm shoving too much at my observers at any time, and they need to say back off a little bit. So thinking about some of those kinds of aspects are actually really important. Also thinking about more on the distributed side of things. Can we, kind of like what we had with Meteor, can we kind of think about the same kind of things where we have distributed collections, distributed communication, etc., all with the power of JavaScript? And then finally, thinking more along the lines of Node.js streams. So Node has this whole notion of streams, and drastically changing in 0.9 and beyond. But it's looking like, how do we merge a lot of these ideas around, instead of just thinking about it being arbitrary I/O, chunked I/O, thinking more along the lines of, if I could merge a lot of those ideas into this library where we're thinking about queryability over those streams. And that's it. Thank you.